Hello guys, welcome back to Mason African Motives, still on engineering science N1. In this platform, we shall be focusing, that is question number 6 on statics from the question paper which was written in July 2022. So we're not going to waste much time. We're going to quickly rush through the questions that we are given. On question 6, that is, the first question is, forces are all around us. All right. Name 2 effects a force can have on a body. Okay, what are the effects that a force can have on a body? Okay, so I've got some of the answers that you can choose to pick from. That a force can try to change the position. In this case, we are given that a force can try to change the position from a body in what? In rest. Okay, a force can also change the position of a body in rest. A force can try to accelerate or decelerate a body in motion, or it can accelerate or decelerate a body in motion. A force can also try to change the line of motion of a moving body, or it can actually change the line of motion of a moving body. So these are the properties that a force can actually have as an effect to the body. Okay, so let's check the other part of the question. Where now we are given question 6.2, pick one below, shows 2 forces working in on a body. So this is working on a body, not like in on. Okay, working on a body. Determine the resultant of the 2 forces by making a drawing and show the parallelogram of forces method. All right, so in this case, we are actually required to apply the parallelogram of forces method. Okay, I want you to check what is happening in this case. The first force that we have is 130. So what you're going to do in this case, you're going to choose a suitable scale that you can work with. In this case, let's say 1 centimeter is going to represent 10 newtons. Okay, so if we are to check, we are supposed to create a parallelogram between these forces. Okay, the first one is 130 north 40 degrees to the east. All right, so I want you to see exactly the presentation of this diagram, how it was going to be like, but you're supposed to have this in an accurate manner. Okay, but here I'm just going to have this as a sketch. So we've got from our North Pole, we are going to have here, I'm going to have a sketch, then I will present it later on. So we have got our North Pole here. This is your north, south, and east, whatever that you have here. So we've got north, west, east, and south. All right. So the first one, we are given that it's supposed to be north 40 degrees to the east. All right. So this is north 40 degrees to the east, which means we are referring to in between north to the east. So you measure 40 degrees, okay? From north to the east, you measure 40 degrees in between here. We must have an angle of 40 degrees, okay? And remember we said 1 centimeter represents 10 newtons. So if you are to check 130 newton, if you divide by 10, it's going to be 13. So this line is supposed to be 13 centimeters to where it is going to be, but that is 130 Newton, okay, which is 13 centimeters according to the measurement. From the same point, there is another force that we are given, which is at 120 Newton at south 60 degrees to the east. So it's from south to the east. So we are moving from this point from the south to the east. So you measure 60 degrees from south to the east, okay? This angle here, it must be 60 degrees, okay? So this is where we are going to have our point. So we measure 12 centimeters because that was 120 Newton. So 120 divided by 10, that's 12 centimeters, but you write as 120 Newton, but you know that this is 12 centimeters. Remember, we are supposed to have this as a parallelogram. So what are we going to do in this case to find the resultant force? This is what you're going to do. You measure from this point, we are supposed to have a same distance from this point to this point, which is 13 centimeters or 130 Newton. You measure 13 centimeters. So from this point with 13 centimeters, you just mark your 13 centimeters. So your 13 centimeters might be at this point somewhere here, all right? We do the same from this point to this point here. We've got 120 Newton, which is 12 centimeters. So remember that parallelogram, these opposite sides must be equal. So which means from this point to this point here, we must have 12 centimeters. So you measure that 12 centimeters, then stepping at this point, you must be at this point. You measure your 12 centimeters, then you mark an arc to represent 12 centimeters. So when these forces intersect, the 13 centimeters for 130 Newton and the 12 centimeters, where they meet, they are going to meet at this point. That is where we are going to take our resultant from. So this is going to be equivalent to 130. If this is 130, this is also going to be 130 Newton. If this is 120, this is also 120 Newton. So the resultant now is taken from this point here. This is where you take your resultant from the point of the forces to the point of intersection here. So you draw a line, straight line from this point to the point of intersection here. This is where you are supposed to have your resultant. Okay, so you measure this line. So if you are to draw this properly, guys, if you measure this line, you are going to obtain 19.2 centimeters, of which 19, so it depends, maybe you used millimeters. I don't know the scale that you have chosen. You choose a proper scale, okay? So 19.2 centimeters, but remember we said a centimeter is represented by 10 Newton. So you multiply by 10, which is going to be 192 Newton. So we've got a resultant here of 192 Newton. But what about the direction now? So the direction, we can take this one from the east line, okay? From the east here, it depends with the way that you can take. We can take from the east to this point, okay? This angle, we can measure this angle here from east to this point, all right? So let's just say this is alpha. So this is east alpha degrees to the what? To the north. I don't know the way that you're going to take, or you can take it from the north, okay? From the north direction to this point here, all right? You are going to take this angle, which is going to be north, a certain angle. Let's say this is theta, that's theta to the east. So it depends with the way that you're going to take, okay? So if you are to measure properly from this line, if you measure this angle between the resultant and the force of 130 Newton, if you measure properly, guys, you are going to obtain an angle of 38 degrees, okay? So you use your protractor to measure that angle, okay? So the resultant is going to be 38 plus this 40 here. So 40 plus 38 is going to be 78 degrees. Okay, so that means our resultant is going to be 192 Newton, then north the theta, which is 78 degrees. So it's 78 degrees to the east. All right, so that is going to be the equivalent. If you measure properly, like I said, please make sure you use your instruments properly. So this is very, very important. And these are the typical questions that you can actually have. All right, so that was question 6.2. So everything there, it was just 2 marks for that. Okay, let's check the other part of the question. Let's see what we are given on 6.3. So we are given Bose notation is a labeling convention whereby the spaces between any group of forces is labeled with a capital letter A, with a capital letter, such that each force is then straddled by 2 letters. 3 forces are working on a body and are in equilibrium as shown in Fig 2 below. All right, so these are the forces that we have which are in equilibrium, okay? So the question is, all right, let's check the question that we are given. Draw the following neat labeled diagrams of the 3 forces shown in Fig 2 above and label the forces using scale 2 Newton. So take note, we are given there 2 Newton to represent 1 millimeter. Okay, so if you are saying 2 Newton is representing 1 millimeter, it means if we are given this one, let's say 66, all right, we are given 66 in this manner. 2 Newton equivalent to 1 millimeter, then you are going to divide 66 Newton is equivalent to, or we do not know. So that's 66 over 2, which is going to be 33 millimeters. But 33 millimeters simply represents 3,3 centimeters. Remember, 1 centimeter is equal to 10 millimeters. So you divide by 10, which is going to be 3,3 centimeters. All right. So if you are to check on the space diagram, nothing is going to change. Everything is going to remain as it is. But now the distance from this point to this point, if you measure 61 degrees, is supposed to be 3,3 centimeters. The same here, you do the same, 115 over 2, which is going to be, we are going to have 5,1 here, which is 7, that's 57,5. All right, so we are going to obtain 57,5 millimeters, which is 5,75 centimeters. So that is what you're going to do each and every force. Okay, so the space diagram, like I said, is going to remain as this one, is what we have. Okay, but we can label the letters just like what we referred here. We're going to label the letters. So you can label A, B, C. All right. So this is our A, our B, and our C. All right. So the space diagram is not going to change. You're just going to take that diagram as it is, but consider the scale. Then the vector diagram. On the vector diagram, this is what we are going to do. We are supposed to combine these forces that we have. Okay. So we are given 3 forces in this case. So these are 3 forces. You just have to connect them, to combine them to formulate everything in this case. Okay, so let's start with 133. I'm just going to have my diagram here. I'm going to utilize this space here. So you use the scale. So the scale is the one that I was showing you here. So I'm not going to waste much time on this scale. So I'm just going to show you what it's going to be like. So from the force of 133, all right, we are going to start with 133, okay? 133 is at an angle of 59 degrees, okay? So which means we've got something of this nature. You must draw a straight line, all right? So if this is your North Pole, okay, 133 is 59 degrees here is somewhere just 90. So in this first quadrant, we can say at this point like this one, all right, going this way. So let's say this is where we have our 59 degrees. So this is going to represent the first force of 133 Newton. Okay, but we can see that this part of C is going this direction, is going down, okay? It is going this way down. Then this one is going also down with 29 degrees. So we can connect the force of 115 at B, okay? So we can connect this point here. It's 29 degrees. So at this point, you measure 29 degrees here. You measure 29 degrees. Okay, so this 29 degrees, then you use the scale to measure this. It was 77.5 or something, okay? The one that we measured before. So this is what you're going to do. You draw your line, okay? So you measure your line, then you draw. That is maybe at this point, maybe somewhere here. Okay, so this is our 115 Newton. All right, then if we are to connect the third force, it's supposed to be 61 degrees, okay? But now let's check the angle that is separated from this force, because these two, they are separated. What is the angle in between here? So we are going to subtract from 180 to find this angle. So that's 180 minus 29 plus 61, okay? Which is 180 degrees minus, that's 10 here, and this is 90. So we're going to obtain 90 degrees. So from this point back to this point where we started, we must have an angle of 90 degrees. So you measure 90 degrees. When you measure 90 degrees, it is going to directly meet at this point. If these two forces, they do not meet, then it means your diagram is wrong. So this is going to be back at 90 degrees, okay? So this is your 66 Newton in this case. Okay, so that is going to be your vector diagram in this case. That's 3 marks for that. Okay, on 6.4, we are now given to make a neat sketch of a single rope pulley system with 3 pulleys in the upper block and 2 pulleys in the lower block. Take note, we need 3 pulleys in the upper block and 2 in the lower block. Okay, so this is the diagram that I want you to have in this case. All right, so let me show you from this one. All right, so you've got this one. So take note, we are given 3 on the upper, then 2 in the below. So that is what we have as your diagram. Just 3 marks for that. Okay, so as you can see, this was pretty clear. All right, let's check the other part of the question. That was question 6.5, where we are given below, fig below shows a beam in equilibrium. Okay, calculate the unknown force F. Okay, we referred to this typical question before on our section A, if you still remember, where I referred to the issue of moments. Okay, from this point, we can refer the moments which are in the clockwise and anti-clockwise so that we can have the unknown force. So remember that the clockwise moments should be equal to the sum of the anti-clockwise moments, or you can start with anti-clockwise moments. I don't know which one is best for you. Okay, so let's check from this point which forces are going to be taken in the clockwise. Okay, if we are to check at F, F is moving this direction, that is in the anti-clockwise. We take 30 is moving this direction, which is anti-clockwise. Okay, take note, this is anti-clockwise. A clockwise is like this. Okay, so that is anti-clockwise. So here we have got anti-clockwise. Here we've got anti-clockwise. If we check 70 Newton here, it's moving this direction, okay, which is a clockwise. So on the clockwise, we only have 70. So it's 70 times 6. Remember that moment, that's force times distance, okay? So force times distance, we're going to have force of 70 times distance 6, which is equal to the anti-clockwise F. Back to this point, there's a distance of 4,5. So that's F times 4,5 plus, we still have another one in the anti-clockwise, you add, this is 30, but if you have to check the distance, it's 4,5 plus 4,5. So there's a difference of 9 meters in between. If you add these ones, that's 9 meters. So it's 30 times 9. All right. So I want you to combine these values. Okay, so let's just show our calculator. Let's just show everything on the screen so that we can have our calculator here. So the first one, that is 70 times 6, so 70 by 6, which is 420. So 420 is equivalent to 4,5 F plus 30 times 9, which is 270 in this case. So we are going to transpose so that we can find the value of F in this case. So if we transpose this to this side, it's going to be a negative. So that's 420 minus 270 is equal to 4,5 F. All right, so let's combine everything here. 420 minus 270, that's from our calculator, 420 minus 270 is going to be 150. So 150 is equal to 4,5 F. So to find F, divide by 4,5, divide by 4,5, this can give us the value of F. So that means our F in this case is 150 divided by 4,5. So 150 divided by 4,5, that is 100 over 3 as a decimal. That is 33,3333 and so on, which is 33,333 Newton to 3 decimal places. Okay, so this is the force that we are given F. That was the unknown force from this diagram that we are given. So it's very, very important, guys, that you understand your moments okay, working with forces in equilibrium. So that was the question 2 on statics, having 14 marks, as you can see. So more questions to come from Meson African motifs till we meet again.